Hi, welcome to episode 3. We're writing a compiler. In the last episode, we scaffolded our project. We're going to write a compiler in JavaScript using Node.js for a little language called Cot, whose grammar we built in the first episode and whose project we set up in the second. In the last episode, we created a whole bunch of files, and I just realized that I did not actually commit anything. So let's do that right now. Git commit -m project scaffold and push that. And there we go. And yeah, now it's not so green over here anymore. Okay, so what we want to do right now is set up our parser test. We actually want to build a parser. And what do parsers look like in, well, a parser is actually driven by a grammar, and these have a particular feel. It's pretty common. So let's get started with making up a little parser. Basically, what we want is a function that looks like this. We want to write a function called parse, which takes in our source code and then returns a representation of the program as parsed. In other words, like a concrete syntax tree. So we want to produce a concrete syntax tree or CST from the source code, right? So in ohm, that is a match object. Because what ohm does is it will give you a concrete syntax tree, but it's embedded inside of a match. And the way that looks is like this. I'm going to write it like so. We say that we're going to get a grammar in ohm. We have to create that grammar first. And then we're going to run a match against the source code. This will give us a match object. The match object has some methods on it, like succeeded and failed. So we'll say if it does not succeed, we'll throw an error with the error message that's in there. And we have to get some of the stuff working right. So let's read in our grammar. So where's our grammar going to come from? So remember, we actually stored the grammar in another file. We actually stored it in cot.ohm. So let's see if we can read in. Let's make an ohm grammar. See, Copilot is thinking that it wants us to write the grammar in line, which is fine, but I'm actually going to bring it in from here. So Copilot gave us a little too much nonsense. Copilot did not know that we actually called it cop.ohm. And so what we really want is something like this. Okay, so that'll read the grammar in, and then let's see, let's make sure to import fs, star as fs from fs, and let's import star as from ohm.js. Copilot got that one right. And basically, this is it. I mean, this is all you need to do for a parser. Now, we need to write some tests for it, obviously. So let's create parser test.js. Parser test.js. And what does a parser test kind of look like? Well, I like to set up tests like this. Let me drop in some pre-written code. And here's what I like to structure this thing. I like to create an array of syntax checks, programs that I think should work. And then I like to set up an array of syntax errors. And then I like to iterate through them, showing that they all work. So for example, let's create first syntax checks. And I'm going to start it with, an empty program. We don't have empty programs in Cot, do we? In Cot, a program is at least one statement. So our simplest program is going to be a break. So let's go back to the parser test and say the simplest program is one that just looks like break. And we want this to succeed. Oh, while we're at it, we'll just say, how about a program with a print? Oh, how about this? How about hello world? Let's do a hello world program. Hello world. And this should be print hello world. Yeah, that's how it should look. And that's good. So these are syntax checks. And then for syntax errors, I like to make syntax errors have a kind of indication of where the program should actually have an error. So I'm going to write a program like this, and my example just says, hey, I'm going to try and make this program with a little let here, but I'm going to have a non-letter at column 7. And hopefully, if things go well, we'll get the error at line 1 and column 7. So the syntax checks have an array of two things, and well, it's an array of 2-element arrays, 2 tuples, where the first part is the name of a scenario that we're trying to test for. And then the second part is the actual source code in the Kotlin language. And as we iterate through all of these pairs, we want to assert that if I parse the source code, that everything will succeed. I want to have a successful match on that, because what we're doing in the parse, remember, is we're returning a match object. I just want to make sure that it succeeds and doesn't throw. That's probably a little overkill to say succeeded twice, but close enough. For the syntax errors, we're going to have a scenario, we're going to have source code, and then we're going to have an error message pattern that we hope to match. And that's what Mocha's assert throws will do for us directly. Okay, I just whipped these things out, so I have no idea if any of this stuff is going to work. Let's make sure that it's saved. npm test. And we'll see what happens. Okay, so assert is not defined. I mean, you can almost know it never works the first time. Import star as assert from assert. Copilot doesn't really know about the modern way of making Node standard libraries prefix with Node, but that's okay, because we know. Oh, still got errors here. Errors. What are the errors? Parse is not defined. Okay, duh. Import parse from parser.js. Is that right? Did Copilot give us that right? If I look in parser.js, I exported parse as a default function. So no, Copilot, you are not right. Parse comes in like this, right? And boom. Okay, well, we got good coverage here, but no, we got a little error here because, oh, I use double quotes for my, I use double quotes in the Kotlin language, okay? So that means, this is probably the issue of trying to rely too much on Copilot, but what are you gonna do? Let's save that. And, okay, again, assert is not a function. Assert dot.ok. Let's try that. This is also a little bit of, oh, look, everything passes now. So both of my success cases passed and both of my non-success cases passed. All right, so what we now need to do now is make sure that we have many, many more checks. So I'm just going to paste all the checks in and talk about them after. All right, I've added in a number of checks finally, multiple statements, different variable declarations, functions with 0, 1, or more parameters, array types in the parameters, different assignments of complex variables, calls within expressions, whiles, make sure that there's no empty block, and hey, I got a number of different things happening over here, and then ors and ands. I dropped in as many as I could think of at the moment. And then for syntax errors, we got non-letters, malformed numbers, see 2 dot, there's no fractional part. There's an E that doesn't have a plus or minus for a number after it. 5 minus with no right operand. Underscore is not an operator. Trying to start an expression with a right parenthesis. Just dropping in x times 5 without actually being in a statement is a problem. I wanted to make sure that I could capture errors on line 2. Ditto over here, got a statement starting with with the right parenthesis, starting with the star. Negation before exponentiation is an interesting one. I don't like languages where we can write stuff like this because, Python actually does the exponentiation first and will give you -4. And languages like Elm will do the -2 first and then give you 4 for the answer. And so it's good to make that a syntax error. So I want to make sure that that's considered an error. I want to make sure that chaining relational operators is an error. A while that doesn't have curly braces because we required that in this language. While should not be an identifier, it should be a keyword. Here's brackets that are strangely, anyway, on and on and on. Subscripting numbers, you get the idea, string literals with new lines. So let's give this a shot and see what happens. And let's see, we got got two errors here. Got a bunch of errors. Let's see what the errors are. Okay, so first error is it doesn't like this -1 right here. And then if you think about it, that's because we never added negation to our language. The only kind of arithmetic we can do, the only kind of expressions we have conditional operators, we have ors and ands and addition, multiplication. We completely forgot to do negation. So let's get negation in here. We can have negation followed by a primary as one of our expression types. So let's put this way up here. This is a good place to put it. And then negate. Let's see if that helps. We're down to 3 errors. That's good. So that did take care of our first 2 errors. So now all of our things that we want to pass, that are good programs pass, but we do have some errors that were not caught. So does not permit negation before exponentiation. The error here is one of expected a, I think you know what? I think it's okay. It's just that the error happened we thought it would happen on line 10, but it really happened on line 9. So that was close. I thought that was a bigger problem. Negation for arguments, yeah. The error is just that I guessed the wrong place. So let's see what happens now. Let's see if we're down to 2 errors. Yeah, we're down to 2 errors. True is not assignable. So I wanted to reject true equals 1 and false equals 1. I think the reason for that is we forgot to add true and false as keywords into our language. So let's go back into our own and we'll introduce some new primary expressions. Let's introduce true and false as keywords. And since they are keywords, let's remember to put true here and false here. Yeah, I noticed about false. That's good. Prettier won't auto format. True and false and save and run the tests. And still have 1 error. There looks like there's an expected bracket of 2, still 2 errors. False is not assignable. It happened on line 7, and the true one happened on line 5. Yeah, I know I'm being kind of picky. So the true happened on line 6. They both happened on line 6. Wait. It says true actually happened on line 6, and the false also is line 6. So yeah, it was just a little false happened on line 7. I was off by 1. And off by 1 error. Imagine that in programming. Okay, look at that. 47 tests, all pass, and coverage is sitting here at 100%, which is a good thing. Last thing to do for this particular video is to see that we can actually run the parser from the command line. It's good and everything. We should always do the test first, but just for kicks, let's see if we can get this running from the command line. Okay, now the trick to doing that is something like this. I want to be able to say src cot.js and then some file name .cot. And then I want to follow that by the word, like I want to see what happens after you parse it, what happens after you analyze it, what happens after you optimized it, and I would like to see what happens when you convert it into JavaScript. This is what I kind of like to do. So I want on my command line to have 4 tokens. The first one's going to be node. The second one's going to be the program they're running. So the third and fourth values should be the file name in position 3, and the fourth one should be the what we want to have happen. So I'm going to begin this program like this. I want to make sure that there are 4 tokens on the command line. And if there are not, we're going to output a help message of some sort. Otherwise, we're going to be okay. We're going to run compile from file where process.argv2, that's this one here, will be the file name, and argv3 will be this one, which means that we want to write our compile from file like so. So our file name and then the output type. The output type is either going to be parsed or analyzed or optimized or JavaScript. It's going to be kind of what we want it to be, what we want to see. So let's set up a try catch over here. And what we'd like to do here is, we'll compile like this. I'm going to, this doesn't work. Oh, what's going on? Oh, this needs a catch. Catch E. Oh, good. And I guess if we have an error of some sort, which is kind of common, then what we'll do is we'll write out the error message in red text and set our process exit code to 1. So this is the way things are going to work. So what we'll do is we'll take our file name, we'll read it in. So we should actually import that, shouldn't we? This is from FS. So import star as FS from SF promises. That's correct. And then we also need to import compile. Let's put compile in our compilers thing. So let's just pretend we have compile from compile.js, which will compiler.js, which we'll put over here. So we'll just do export default compile and function. The completion really is kind of funny, isn't it? All right, so we'll have this here just to make our thing a little bit happy. And then the idea is we're going to do our compiler here, and then we'll take the particular output type that we have. And for right now, let's just console.log the result we get, console log whatever we get from the compiled version. All right, so our main program is going to be this. Check to make sure that there's exactly 4 tokens on the command line. If not, we'll write out some help. So I got to put in a little help thingy over here, right? So let's say const help. Yeah, usually it's going to be some kind of usage thing over here. So Copilot is giving us some thoughts over here. So maybe we can say something like the cot compiler, and it should say something like this is the syntax. So maybe we'll just say syntax. We'll say node JS file name output type, and the file name is path to the file and output time. And then what should we do for output file? So it should be I like how they're suggesting it should be st. I think it's going to, in our case, it'll be the word say parsed to say whether the syntax is correct, analyzed, to show the internal program representation, optimized to show it optimized, then JS for JavaScript. Yeah, that's good. And that will be this is our help thing if we mess up. All right, I like that. And then we'll show help. Otherwise, we'll call compile from file. We'll pass in the program to compile as the name, and then we'll get it all working over here after we call compile. So now what our compiler is going to look like is it's kind of, well, right now we don't have a lot of our compiler written, but we do have the source code and the output type. And we can say something like this. All we have right now is the parser. We'll just say if output type is parsed, then we'll parse the source code. For analyzed, we'll analyze the parsed source code. Okay. Pretty good, I must say. We'll generate the optimized of the analyzed of the parse code. I mean, I guess that's okay. I think we could do a little bit better than this, but I think for right now, it's totally fine. I think what we can do for right now, though, is all we're able to do is parse. So we'll get back to this a little bit later, but we'll just say right now that something like only the parser is implemented. We can get back to the other thing later. Let's remember to import parse from that parser. Copilot might not put the JS on here sometimes. I think that's a little bit of a problem over here. So this thing's actually going to return the match for us. So, I mean, let's see how this works. I need to actually have some example programs to try to compile. So let's do that right now. I'm going to drop in here at the top level. Let's put in an examples folder, not a file. Hey, should just start using Maker examples and then touch examples hello.cut. I mean, why not? Why not? Why not start easy? Print. Hello, world. Hello, world. Okay, there we go. And now we can say node src cut.js examples. Well, actually, let's do fewer than one. So if we give the wrong number of arguments, it's going to give us the help message. So that's good. If we do give it the right number of arguments, let's see, examples, hello.cot. I'm going to see it parsed. Hey, look at that. It actually works. This is some information from Ohm. Ohm actually gave us a match result, which actually has a lot of information in it. Somewhere in here, you'll see the input is print hello world. And somewhere they've tokenized it. You can see you got the program rule is in there, and there's some other stuff that is not being shown in the output because you don't want to get a big bloated output, and Node.js is just giving you a smaller piece, which is kind of nice. If we don't say parse, but we jump over to analyzed right now, we get our error, only the parser is implemented. And if for some reason we have a program that does not exist, it'll say no such file or directory. So we're getting errors, we're getting print and read, and for code that does parse properly, like this one here, examples hello.cot, that works. If it's a little bit ugly to actually show the match object, which it might be, you can, and you might want to say something like this, console.compile, but you could say if output type is parsed, then we could just say syntax okay. Otherwise, otherwise we'll just show the part that's compiled. And now for things that are successful, it just says syntax okay. And then if anything is wrong, we'll get an error. So now the parser is wired in. We have a command line option to run our compiler, which for now just runs the parser, but later will be extended to do other things. And speaking of other things, coming up in the next video is going to be the phase of the compiler known as static analysis, whose job it is to not only check to make sure that there are no semantic errors, static semantic errors, as we say in the program, but also to generate an internal program representation. And that's probably the biggest part of the compiler. So I'm going to be breaking that down into like 2 or 3 videos. But for now, thanks for watching. I hope that was useful.